Hi everyone, welcome to tutorial 3 of the NLP sentiment analysis project developed for the Big Data Hackathons. This third tutorial is about finally using machine learning to perform the sentiment analysis. So in the second tutorial, we showed, using existing Python toolkits for doing a very simple form of sentiment analysis, which in some cases can be useful, but obviously there are advantages to using machine learning. It's a lot more sophisticated, a lot more powerful. Okay, so let's get into it. So as we explain in the introduction, we just talk a bit about what machine learning is and the fact that we'll be using supervised machine learning in this tutorial. So just to look at the contents here, we have section 1, which is on using classical machine learning approaches. So basic classification models that exist on scikit-learn, and just basically preparing data, extracting features from text, with the text, which is our data, and then building a classifier model and making new predictions on using that trained model. And then we look at transfer learning and the advantages of using transfer learning, specifically with NLP. And within transfer learning, we'll look at 2 language models that we use. One is the BERT model, and the other is COVID Twitter BERT, but we'll get into that just now. Okay, so let's start with section 1, which is on the classical machine learning approach and supervised machine learning in particular. So in this tutorial, we don't touch at all on unsupervised machine learning, just for the purpose of NLP. Okay, so we just explain here what supervised machine learning is, where you have labeled data, and you have your your features, which are which it learns from to sort of tell whether something is a specific class. So in our example, it's obviously going to look at the Twitter text and try and put together features that are most likely to be of a negative or positive sentiment. So the classes are our negative and positive sentiments. Okay, so the libraries needed are all very simple for this section. Mostly, just different classifiers from sklearn, and then a few that we'll need for extracting the features from the text, which is called count vectorizer, but we'll explain how that's used coming up. Okay, and so for this first section, we're going to use the same data set that we used in tutorial 2. So it's basically 4,200 or so tweets, which have been manually labeled. And this data has been pre-processed already. And we're going to use this as the training and test set. So I've already run all the cells here, so just to speed up, because some of them, when you get to the transfer learning, can take some time. So everything is run and there's already an output to show you. Okay, so if we look quickly at just some data preparation, I just wanted to teach participants, that you should, before you just go ahead and start with, using your data for training or machine learning, you should just have a look at your data and know what you're working with, and make sure there's no, for example, bad or missing data that could influence your results or disrupt what you're trying to do. So I mean, we know that's usually true for numerical data, but it's also true for text data. So if we have a quick, we have our data frame, df, and then if we just say df.info, very quickly it will give us a nice little summary of how many rows we have in total, and then for each column, how many non-null objects we have. So here we see that there's a discrepancy, and that we have, for the label, we've got 4229, but for the actual tweet text, we have 4220. So there is this discrepancy where there's a few columns basically where there's no text at all. So this basically happened whenever we did the pre-processing and we removed stop words. So there may have been some very short tweets that consisted only of what we classified as stop words. So when we did stop word removal, we actually removed all the words in the tweet, leaving us with an empty column and missing data. So I just explained here a bit about how you normally deal with bad or missing data, and in this case, all we're going to do is just drop the whole row wherever we have a null value in either column. So that's normally, I mean, if you're looking at numerical data, you might choose to delete rows that have missing data, or you could choose to sort of average, take an average of your other data to fill in those rows. But in our case, obviously, we're just going to drop the rows very easily like this. It's just df.drop.na, and when we do df.info again, it will now show that they have the same number of entries. So all those rows where there was no text from the tweets have been dropped, and we're now good to go. Okay, and now let's have a very quick look at the distribution in terms of our sentiment labels. So the way that when we labeled manually, the way that we labeled our tweets regarding to sentiment was 0 was for negative sentiment, 1 was for neutral, and 2 was for positive. Now you may wonder why we didn't say -1 for a negative sentiment, 0 for neutral, and 1 for positive. And this is because if you're going through thousands of tweets and doing thousands of labels, it's very easy to make a mistake when you're entering -1 and 1. So to try and avoid that mistake occurring, we chose to go with the labels 0, 1, and 2. Okay, so again, yes, 0 is a negative sentiment, 1 is neutral, and 2 is positive sentiment. Okay, but obviously we wanted, for the purpose of a hackathon and this tutorial, we don't want to make the task too difficult, so we're actually going to just work with a binary classification task. So we're going to look just at 2 classes, being positive sentiment and negative sentiment, and actually just leaving out all those with neutral sentiment. Even though this does obviously cut out a lot of data, it would be a much more simple task in terms of classification. So, and then for it to be more intuitive for everyone, we're just going to change the actual label. So, when you do this, so we're going to change the labels from being 0 and 2, which they currently are, to 0 and 1, just for simplicity and being intuitive. Where 0 will be negative tweets and 1 will be positive sentiment tweets. So because we're replacing something in the original data frame, we get this little warning here just to say, you're going to alter your actual data, but that's okay. We can just, as I've said here, we can just ignore this warning that occurs because we're trying to reset values in a data frame. But yes, we're replacing all the twos with ones. So now after we've done that, we see that if we do value counts, it's correct in that the positive tweets, what was labeled with 2, is now labeled with 1. Okay, so negative tweets, tweets with negative sentiment, tweets with positive sentiment. Okay, and now we notice immediately that there's, that it's not balanced, in that there are far more negative tweets with negative sentiments that have been labeled as negative than positive, and that's just something you can't get around when looking at tweets concerning COVID-19, because let's face it, most of them would have some sort of negative sentiment. What we do then is to try, oh, sorry, not sure what's happened yet. Let me just fix that quickly. Okay, sorry, I pasted something in here by mistake. All right, so yes, we have an unbalanced data set, and that can cause problems potentially, because, if you train a model using an unbalanced data set where you have far more of one class than the other, then it just means that your classification model is going to be biased, basically far better at predicting sort of tweets that have negative sentiment than positive, and this, we wouldn't want such a classifier, especially, if you're dealing with, the numbers of the data entries that we have, you don't want it to be unbalanced. Maybe if you had hundreds of thousands of data entries to train with, then it would be maybe less of a problem. But in our case, we would definitely see a biased classification if we were to go ahead, at least for the for when we're using classical machine learning in section 1. In section 2, we'll see if it's the same situation or not when we use transfer learning. Okay, so what we've done now is, in order to make it a balanced, so yes, before, when we changed the data frame to having just 2 classes, we called it binary DF, binary data frame. And then now we're going to try and create the balanced binary data frame where they both have the same number of entries. So we just randomly sample from the one that has more, obviously, the negative tweets to create a similar, the same size data set, same size number of entries of the positive tweets as negative. So after running this, and we have a look at the value counts once again, we see that for the balanced binary data frame, we now have an equal number of positive and negative entries. Okay, so we now move on to feature extraction. So extracting our features from the text for machine learning purposes, so that the model, can learn basically what kind of text or what kind of features from the text indicates a positive sentiment and what kind of features indicate a negative sentiment. Okay, so in NLP, one of the common ways to do this is where, you have to sort of put or make the text you have to change it to a form that a computer can understand, right? Because the computer doesn't understand text, it understands numbers. So we need to, in some way, numericalize our text. And this process is called vectorization. And it sounds, maybe a bit confusing and intimidating, but it's actually quite simple. Firstly, you need to know that there's a term called tokenization. We've already dealt with in the cleaning and things functions that do tokenization, but tokenization just means where you split the text into individual words or tokens. So that's all that means. So here I've just I've said that we're going to use the balanced binary data frame. I've also got here, which I've commented out, the binary data frames, and if participants want to, after running it with the balanced binary data frame, they can come back and comment out these two lines and keep and uncomment the binary data frame, just to see what the results look like if you don't use a balanced classification. If you don't have a balanced labels or balanced classes when training your model, and how it affects the final results of the classifier. So that's if they have time, if they want to come back and just see. It doesn't take that long, to run. So they can just come back here and comment these out, and uncomment these and rerun everything again. So yes, I just explained here that we commonly use an 80-20 split when choosing how much to use for your train and test set. Just because you want enough data to train on, you don't want your training set to be too small, because then the model would learn from the specifics of that small data set, which could make it biased as well. I mean, I didn't really go here into sort of cross-validation methods and things like that, because it's quite a long tutorial already. And I've tried to keep it rather short and simple, especially because for the hackathon task, I would expect everyone, or most teams or all teams, to actually use the transfer learning for the hackathon task, because it is just so much more powerful. Especially because we don't have that many data entries. We're looking at less than 1,000 for each class. So the classical approach isn't going to perform very well. So this is more just to show them these methods and what it's like. But in terms of actually making use of one of the models for their actual task, I would advise that they all use the transfer learning models, as we'll see they perform much better. Okay, so yes, we're gonna do an 80-20 split. And now I'm going to just explain what this whole vectorization thing means. All right. So in order to sort of, like I said, give all our text or all our tweets a numerical representation, we do something called vectorization. But before that, it's, let's just explain what we're actually doing, and it's actually quite simple. So it uses what's called a bag of words method. If you're familiar with NLP, then you'll come across this term quite a lot. And all it means is that given any text, or what you do is you create a dictionary or vocabulary of all the unique words in that corpus. So corpus just means all our text. So that's what's done first, is you create a dictionary or vocabulary of all the unique words. and then you count the frequency of each word. So in each document, or in each tweet in our case. So how many times that word occurs. And we, in this case, stop word removal is very necessary, because you want your vocabulary or dictionary to be made up only of words that will contribute to the sentiment of your sentence, of your text. You don't want to fill up your dictionary or vocab with words that are not going to have any effect on the sentiment. So I give a simple example here where we look at the tweets. This day is a beautiful sunny day. Okay. And after removing stop words, it would look something like day, beautiful sunny day. Okay. So if we were to do this, this bag of words method for this simple sentence, which we can consider being one tweet. So if we first create our vocabulary, the unique words are day, beautiful, and sunny. Okay, so that's we're not looking at the occurrence of each word here. We're just looking at each unique word. So that's these three words. And then we would say the next step is to count the frequency of that word. So the word day occurs twice, word beautiful occurs once, and the word sunny occurs once. So then this number now, 211, is now the vector or vectorization of that sentence. So we've now been able to numerically represent our sentence, this day is a beautiful sunny day, with this combination of 211. This is obviously a very, very simplified example. I'll show a bit of a longer example here. So this is what it would look like if we had if we use the bag of words method, and what happens is a matrix is created, which is what we call a term document matrix. Okay, that's what this is here. And that's where you just have all your documents on this side. So it could be, in other cases, like legal documents or medical reports or anything. In our case, our document refers to each tweet that we want to look at. So our 4,220 tweets would be on this on the columns, the rows. So, and then across here for our term document matrix, we would have each word. So obviously I've simplified it again just for example, but you would have a whole long, many columns here with all the unique words from all the tweets combined. Okay, so these are just words that I put for example, which we would expect to see in words tweets about COVID-19. Okay, so that's how it would work. And then the occurrence of each word in tweet one would be counted and put in here. And you might have obviously tweets where the words don't occur, so those will have zeros. And then you come up with so in this sentence, the word virus occurred twice, the word mask occurred twice, school didn't occur at all, cough occurred once, etc. So then this number 2201100 is the vector, vector representation of that tweet. So that's what the computer will be able to understand and draw features from. Okay, so this sounds, it's quite intuitive, but you would think like, how do we go about doing this? And luckily, it's made very easy. Where there's the sklearn library has something called Count Vectorizer, which does this all for us with very little effort. Okay, so here we'll just call Count Vectorizer CV, and what you do is you just say that you're going to look at each word and the n-gram range. So n-gram just means how many words you're going to look at a time as a token. So, each token will comprise of unique words, but we're also saying you can use combinations or what's known as bigrams of size, n-grams of size 2, meaning bigrams. For example, like infection rates, which might be important, the occurrence of such two words together. Usually going higher than that in n-gram ranges complicates things a bit. So we're just going to stick with a range from 1 to 2. So unique words and also bigrams, like here, for example, New York or infection rate. Okay, so how it works. So to get the training features, we just say, so we're using CV as count vectorizer, cv.fit_transform. And what this does is fit identifies all the unique words in the corpus. So it creates that dictionary or vocabulary, and then transform counts the occurrence of each word. So those two together will create this matrix. Okay, and then what we do is on the test data. So that we want the features for the training data, and we want features for the test data as well. And for the test data, you'll notice that we do cv.transform. We don't refit. The reason for that is you want to use the exact same vocabulary as you as you had for the training data. You cannot create one vocabulary for the test data and a different one for the training data, because then you're not going to get even the same length of vectors. You're going to end up trying to compare apples and oranges, basically. So you want to, for the test data, we have to use the same vocabulary, the same dictionary that was used for the training set, which is why we do transform but not fit transform on the test data. Okay, and then we come to building the classification model. Here I just explain a little bit about how there are a few models that researchers have created over time, and they're well known and used very often. And thanks to the really great scikit-learn library, we can very easily make use of these models to test them out and see how they all perform for our specific classification problem. I think you'll go over some of these in the classes, which will be great, but there is links here for participants to read up if they want to go and read up more on each of the models. It's not necessary for the purpose of the tutorial or for the hackathon task that they understand these models in detail, because like I said, for the hackathon task, I do hope that they will actually use the transfer learning. So it's more for their interest's sake, but just to explain to them that certain models or certain classifiers work better for certain problems. So they can, basically I've just reinstantiate all of them, and then it's very easy for them to just come here and change and use whichever one they want to. If I remember correctly, the decision tree classifier is actually the one that performs the best for this problem. So I've got it in here, but they can go ahead and change it to LR for logistic regression or SVM or whatever they'd like to. They just come here and change it and then rerun everything after this. Okay. All right. So we're going to create the function to use the classifier to train and the training set to train the model. Very straightforward. It's just called classifier, and you fit using the training features and then predict for the test features to see how it does. All right. I explain it all a little bit so that you don't have to go over it again as they're going through it, but they should understand the basic how the basics of machine learning works by this stage in terms of the training and the test validation sets and things like that. So we then want to know how it performed, obviously. So we're going to use these metrics that I think you do go over in the lessons as well. But I do send out in the prep material, I do send out some information on metrics and model evaluation. But we're going to use the basics of accuracy, precision, recall, and F1 score, and the confusion matrix, and just look at the classification report, which is always just useful. Okay, so you can see, just very quickly looking at it, F1 score of about 65. So not great, not terrible, but not great. Definitely not good enough to use for any sort of research. So this is why, for the amount of training data we have, I wouldn't expect it to be amazing. And that's one of the problems with, often in machine learning, coming across or obtaining enough training data is very often a problem. And it's especially the case with NLP. So that's why using something like transfer learning is so beneficial, because it's so powerful, even with small training sets. So, but we'll talk a bit more about that very soon. Okay, and then I just show them how to make new predictions. So once you have a trained model, because they're going to have to do this for the task, they're going to have a model that's, after they run this code, the model is, the classifier is already trained, and then they will just use it to make new predictions. Like I said, I don't expect them to actually use the classifiers of shown in this section, because they don't perform that well compared to the transfer learning models, but I just want to show them that this is how you do it. Okay, so for just demonstration purposes, I take the new tweets to be just a subset of the data that we already had in our data frame. So, 20 rows here of the tweet text, but for them, it will be the text from the tweets that they actually go and collect. Yeah, that's the new tweets. It's just for demonstration that, we've got 20 new tweets here. And then if we want to get the features, we need the features for these tweets, but obviously we don't want to fit again because we want to use the same vocab that we created before. So we only transform for the new tweets to get the features. And then we use these features and just say classifier. So this is the classifier that's already been trained, .predict, given the new features. And these are our sentiment predictions. So these are predictions for new unseen data. This is just showing them, the concept and how you go about doing it, because that's essentially what they will have to do. But I'll explain it a bit more now, going to transfer learning. Okay, yeah, but this is printed out an array of sentiment predictions corresponding to each tweet. So positive, negative, yeah. Okay, now we finally come to transfer learning. I'm sorry, this is quite a long, this is the longest and hardest of the 3 tutorials. And it will take them the longest to go through and might be the most challenging for them to understand. But like I said, I hope all the explanations I provide is helpful. If they go through it slowly while reading, the text and not just running the cells, they should be able to, understand what's going on. Okay, so transfer learning is a type of deep learning, I guess, but it's where there's only one layer. So we're not really using deep learning. I just explain here what deep learning is, and that it's a neural network which has an input layer, a few hidden layers, and an output layer when you're training the classifier. So I just explained that deep learning models are extremely useful, but they still require a lot of data. And like I explained for NLP, it's hard to come across huge training sets. And in addition to that, a problem specific to NLP is that language is very complicated. It's very complicated as a problem for a computer and for things like sentiment, because language is it's a human thing, it's very nuanced. It's, there's so many aspects of language that are just so difficult to try and teach to a computer. So we use transfer learning because the model, it benefits from having looked at millions or a really large number of texts just to first understand language, the rules of language or the basics of language. So we call this a language model, where in our case we're going to be using a language model called BERT, which is basically it's a classification model or a language model, sorry, that's been trained on millions and millions of Wikipedia text, text from Wikipedia articles. So after this, this has been trained, you're not starting at zero as your initial layer. You're starting with something that already understands the rules of language. And what a language model, what makes a language model good, or is that it will be able to predict the next word in a sentence, so or the word before it and after it. That's basically, it will understand the basics of language to be able to at least do that. So the idea is that, yes, you have a model that's already been trained on a lot of text so that it already understands something about language and the rules of language. So it's referred to as a pre-trained language model. And we'll be using BERT, which I'll talk about a bit just now. So there's 3 steps in transfer learning. The first is to use a pre-trained language model, and we'll be using BERT. Then you take this language model and fine-tune it according to your specific data. So obviously the language model is on all types of text about all types of topics, etc. The point is just to teach it language. But in step 2, we want to fine-tune it for our data. So in our case, our COVID-19 tweets. And then the last step is to use it as a classifier, so that we train it to look for our specific classification problem, being sentiment analysis, so to predict sentiment labels. Okay, so those are the 3 steps. And I think I talk about it lower down, but we're going to be using something called, similar to how we had sklearn, we're going to be using something called simple transformers, which, there's many ways to actually make use of BERT, the BERT language model, but simple transformers makes it a lot more easy and a lot more simple. So especially for the purpose of novices or the kind of participants we'll have, this will be the easiest way for them to implement something that's quite complicated or quite intense in machine learning. Okay. Right. Another important thing to note is that we're going to be using a different data set here. We're going to be using data that is the same data set, but that's been just cleaned, not pre-processed. And the reason is we do not, for this case, for the case of transfer learning, you do not want pre-processed data where you've removed stop words and put everything into lowercase, etc., because the BERT language model has been trained on millions of pieces of text that look like normal text with, you know, uppercase and lowercase, although you can specify whether you want it to be case sensitive or not. The BERT model, you can specify that. But you definitely don't want stop words removed because that will not represent the text that BERT has been trained on, which is text that has all the stop words included. Okay, so here we just use data that's been cleaned but not pre-processed. I do explain all this in the tutorial for the participants, but just for your understanding, and if you get any questions about why it's different. Okay, so just like before, we create a binary and a balanced version of this data set. So we're going to have ByDF and Bell ByDF, I've called them. So just as before, and then split it into the usual 80-20. And I've just shown here how it's done the split in terms of the number of, for the training and test set, how many positive and how many negative tweets are in the training set and in the test set, just for interest's sake. Okay, so here we come to actually now using BERT and using transfer learning. So I've put in a little warning here for each participant to please get permission from a tutor before running the cells below. This doesn't affect different teams. So if you have someone from different teams wanting to run this at the same time, that is fine. Each team has their own virtual machine. So if whatever one team does will not affect the compute power of another team, because they each have their own resources that have been allocated to each virtual machine. But it does impact those within the same team. So if you have 4 members in a team and they all try to run this training at the same time, it will create problems and it will not work because all the resources will become overloaded. So ideally, you want one person in the team to run the following code and the others to look at the output. And if after one person has run it, the others want to run it on their own computer, they can do so, as long as they take turns and not try and run it at the same time. Okay, and this is partly because IDEA's resources use CPU, and BERT is actually optimized for GPU performance and not CPU. So it's a very small and avoidable issue. Okay, so then here I just explain what BERT is. They definitely do not have to go into this to really understand how BERT works. It's very, 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 very complicated and involved to actually understand how a language model is built and trained and things like that. But for those who are very interested, I've linked the paper here about the BERT language model. But basically I've said what BERT stands for, and that it's bidirectional, which is what makes it powerful. So it can look at words before and after. It looks at a word before and after the word that it's trying to learn about in a sequence. So yes, bidirectional. Okay, and then I talk a little bit about the simple transformers library, just like the sklearn library. And if they want to know more about it, they can go to this link, but again, not really necessary to understand this in depth. during the hackathon, they can go ahead and look at these kinds of things after the event. They will still have access to all these tutorials. So they can go and read more if they're intrigued and if they want to understand more. But simple transformers just allows us to very easily implement this BERT model. Okay, so I've also just said here that to please ignore there's going to be a lot of blocks of warning output that comes up when you run these cells, and it's fine. You just ignore it. They're just guidelines from some simple transformers with regard to the BERT model. Okay, so here we're just building the BERT model, saying we're using BERT and we're using the case sensitive version of BERT. We have two classes. We say use CUDA equals false, just means we're not using GPU. And we go ahead. So again, I just want them to have just checked with the tutor before they run this. So just so that there's not all four in a team trying to run it at the same time. So once they've gotten your permission as a tutor, and you've told them that only one is to run this in the team at a time, or they don't each have to run it, but if they do, they need to take turns within their team. Okay, then we come here and train the model. So I do have the time magic command afterwards to print how long it took, but with ideas resources, I do state here it should take approximately 4 minutes. It took 11 minutes running it locally on my laptop. Right, so this is just training the model, and we always have these very nice progress bars that come up, so we can tell how slow or fast it's going, and have some idea of how much longer we'll have to wait. Okay, and then we just have these, it's simple wrapper functions, which to be able to use these performance indicators like the F1 score and the classification report from sklearn. We have these simple wrappers so that this can be used by simple transformers. Okay. They don't really have to understand this. It will output the similar sort of classification report and F1 score and things as before. So first here, we're just this is going to output the F1 score by using multi-F1 function, and you can already see that it's doing quite a bit better than before. And I think this is using the balanced data frame, so data set. Sorry, let me just yes, okay, no, this is using the binary data frame, so not even the balanced one. This is actually making use of more of the data. So with the classical approach, if they tried using the unbalanced set for training, it would have created some issues. But we'll see with transfer learning that it's not really, there is still a discrepancy, but a very small one in terms of how biased it is or how much better it is at classifying one class over another. Let me just go back down. Okay, so F1 score is looking considerably better for the same amount of data. They can rerun this with using the balanced binary data set as well, and see how it compares, so that they can decide what they'd like to do. But I think, with the very low amounts of data that we're going to have, that it's good to use as much of it as you can. So here you'll see the discrepancy is not very big. So we see that because there's double the number of negative tweets with the negative sentiments class, but the overall, the performance here for F1 score is 89 versus 79, which is, it's something you can bear with, something you can live with in terms of being able to trust the predictions that come out of this kind of classifier. Okay, so yeah, this is that's the end of BERT and how it performs. They can rerun it using, like I said, the balanced data set just to see if this improves greatly or what it looks like and make a decision. But I've run it for the first time with using just the binary data set, not the balanced binary data set. Okay, and then once again, as I showed in section 1.4, how do you use your trained model then to make new sentiment predictions for new data? So because they're going to, in their task, collect new data and use their trained model. So the model's already trained, they don't need to retrain it, but they'll need to make predictions. So just like this, and obviously this time there's no need for vectorization because we're not using the bag of words method or any vectorization. Here we're using transfer learning and the BERT language model. Okay. So, all right. So yes, it's just putting in your new tweets and BERT model.predict, as easy as that. And you get sentiment predictions for each of the new text inputted. And as before, I've just used a small snippet or a small sample of 20 tweets from the data just for demonstration purposes. They will use text from the new tweets that they collect. And this is their array of data that's output. Okay. Let's go on. Okay, so for the very last section, we make use of another language model called COVID Twitter BERT, or CT BERT for short. And all this is it's exactly the same structure or the same methods that BERT uses, except that the CT BERT model was developed by a few researchers from this digital epidemiology lab in Switzerland, who decided to create a new language model based solely on COVID-19 related tweets. So it's very, very relevant for our exercise in that instead of BERT, using BERT that was trained on random text, it was, millions of Wikipedia articles. COVID Twitter BERT, CT BERT, has been trained on tweets that are about COVID-19. So we should expect better results using CT BERT. It isn't essential if participants are running out of time in terms of going through the tutorial, and they still haven't done section 2.2 and it's time to start the hackathon task. I would advise that they leave out using the CT BERT and just go ahead with the hackathon task and make use of the BERT model, as I think it performs sufficiently well to be able to get meaningful results for their research question and for their presentation. So, but for those who are on schedule and are able to, they can definitely try out using COVID Twitter BERT. So I won't go through all the code in detail because it's exactly the same as for BERT. Again, ignore all the warning. It again does take a while to train, so they will need to get permission from one of the tutors, from one of you. So you can see when I ran this locally on my laptop, it took 38 minutes. but it will be much quicker when using ideas resources and using their running on their virtual machine. Okay, so let's see, how did it perform? So just a bit better, yeah, as you'd expect. So what was BERT was about 83, and here we have CT BERT with closer to 90, which is wonderful. This is also using the binary data frame, so that's not balanced. So we're using all our data, or you know, we didn't throw away half the negative tweets. And again, you see that it's not that biased. It is obviously, but not to an extent where it would cause significant mistrust or issues with the results, with the new predictions that it makes. So, but once again, they could definitely run this for the balanced binary data frame if they wanted to do that and see how that changes the F1 score. It just means they'll have less data, half the amount of negative tweets. So yes, that's it. That's the end of tutorial 3. I hope that's been clear. Again, I just tell them what they should be able to do, what they should have learned from this tutorial. And then right here at the end, I tell them what the hackathon task is. So this is obviously very important because this is what they will be presenting on at the end of the hackathon. So the task is to think of a research question where sentiment analysis can be used to gain insight into topics related to COVID-19. So they have to come up with this research question. At past hackathons, people have done things like, looking for tweets specifically about vaccines and the, COVID-19 vaccines, or people have done sort of whether, people's tweets about whether people thought COVID-19 was a hoax or fake, or whether they, trusted the scientists. So they came up with that kind of research question, that how do people perceive this COVID-19 pandemic? And so groups come up with their own research question, and sometimes you will get more than one group coming up with the same research question, which is not necessarily a problem. I think it would be a problem if all 4 had the same research question. Then you might want to chat to people, and the ones that came up with it last or something, and say, this is already being done by that team, etc. Maybe you can think of something else. But yes, they have to be very creative in coming up with their research question as a team, and it's a good skill for research. It's a good skill to learn at the hackathon. So then I explained to them that once they have their research question, they've decided on a research question, they then need to collect data. So their research question can be, it can involve a specific country or comparing tweets from different countries around the world, but they must bear in mind that if they choose countries, in Africa, for example, where there aren't a lot of people tweeting as much as, say, maybe even South Africa or other countries in the world, or the UK or America, then it will be, they will collect fewer tweets. And that's all right. That's okay, as long as it's a sufficient number of tweets to be able to make some sort of conclusion. Remember, the data they collect is not going to be used to train the model. The model is already trained, because to train the model, you need labeled data, and we obviously do not expect them to sit and label data. It takes many hours to label thousands of tweets. So the idea is that they will use, that's why we've given them the training set to train their model. They will use the trained models to then make just sentiment predictions for the new tweets that they collect that are relevant to their research question. Okay, so I tell them you will need to collect Twitter data from one or multiple regions in the world relevant to the research question. They'll prepare the data. So based on what method they want to use, they will clean or pre-process. So hopefully if they choose to use the transfer learning, which they really should, because it performs so much better. Or I mean, they could use a few of the different models if they want to. It's all up to them, what approach they take to what they want to present to us at the end of this. So they will either clean or pre-process, because for certain methods you want to only clean, and others you want pre-processed data. And then they'll make use of, so I say make use of existing sentiment analysis tools or machine learning models to predict make new sentiment predictions. And then based on these predictions, so they'll have, say they've collected 2,000 tweets, and they have now from one of the methods obtained a sentiment prediction for each of these 2,000 tweets. They then need to draw some conclusions from this data. So plot some graphs, or how they choose to present their findings is also part of the task. In what way they want to show what they found. So it's all quite fun and interesting. Remember, the presentations are very short. They're just 5 minutes long. So we don't expect them to do, write a research paper or do anything very complicated by any means. It's just a simple task. They should enjoy it and hope to make some sort of, reasonable conclusion based, with regard to their initial research question. Okay, I hope that's been useful. Sorry, it's taken quite some time, but I hope that it's made everything quite clear. And thank you so much for your time. Bye.